So now let us discuss a new topic which is forces in equilibrium. Now, in order to define the equilibrium, equilibrium is defined as the condition of a body which is subjected to a force system whose resultant force is equal to zero. That means what? Suppose if you see figure 2.1, now here there are two forces, right? In both the directions. Now, for this system to be in equilibrium, the resultant of these two forces will be equal to what? Zero. Now, the equations of equilibrium for a concurrent and coplanar force system. You all know what is concurrent and coplanar force system. The coplanar force system is the force system which lies on the same plane. Okay, and concurrent means what? Start. Now, if you form a same point. Now, if you see here, the resultant of concurrent coplanar force system is a single force through the point of occurrence. When the resultant is zero, the body of the force is said to be in equilibrium. If you can see in the second figure, means what? This is a coplanar and concurrent force system. Now here, if the resultant of all the forces that are acting on it, if we resolve this into same directions and if this turns out to be zero, then we can say that this is in equilibrium. Okay, which means that the sum of the x components of the forces of the system is equal to zero. Is it clear? Now, from the previous figure, that is the sum of the x components of the forces of the system is equal to zero, and the sum of the y components of the force system is equal to zero. Then this is called equation of equilibrium. Okay, that means what? You can see that f of x equal to 0 and f of y equal to 0. In a similar manner, if we find out the moments, then the moment about point A and moment of B, MA and MB should also be 0 for the system to be in equilibrium. Let us take a question now. So P and Q are two forces acting parallel to the bar AB and is supported by a peg. Okay, so that it can remain horizontal. If the length of the bar is L, find the position of support O from both sides. Now look, we have to find out what? We have to find the position of support O from both sides. So now let us discuss the solution. First of all, you have to draw what? You have to draw a free body diagram of the member group of members on which some of the unknown forces are acting. Okay, then first of all you have to draw the free body diagram so that you can determine the unknown forces that are acting. Then you have to determine the number of independent equations of equilibrium of the force systems. That means in the force system you have to determine the independent equations, that is f of x equal to 0, f of y equal to 0, and compare the number of unknowns of the free body diagram with the number of independent equations of equilibrium. So after that you have to find out the number of unknowns of the free body diagram the number of independent equations of the equilibrium by comparing these two, and then finally solve the unknown according to the equilibrium equations and then just get the results. Okay, thank you.